My name is Bob Kreiner. I'm the co-founder and CEO of Stralis. We make emission-free hydrogen electric aircraft. Our aircraft can fly 10 times further than battery electric aircraft, whilst being 50% cheaper to operate than current fossil fuel powered aircraft. And that's where we're innovating with our high temperature PEM fuel cell stacks. Current fuel cells are not lightweight enough to make an aircraft application possible. So we're developing a fuel cell that's 6 times lighter in power to weight than the current state-of-the-art technology. And so that breakthrough in fuel cells really unlocks us being able to build hydrogen electric aircraft that can fly useful distances and carry useful payload. The thing that I'm most proud of is that we're working on a problem that the world really needs to solve. I think the world needs a future where we can fly emission-free. The longer-term vision is to get to building clean sheet airplanes, so like brand new aircraft designs from the ground up, leveraging the advantages and differences between hydrogen and kerosene powered aircraft. But we're aware as a startup, going straight to a big brand new aircraft is very capital intensive and risky. So we've broken the problem down into smaller steps. So we're starting with the Bonanzas that are behind me. That's an already existing aircraft that we're just replacing the propulsion system in it. And the reason for retrofitting is it makes it cheaper and faster to bring a product to market.
Aerospace has some unique challenges, particularly around weight and power density, and hydrogen's a really good match in that application, particularly for the space that Stralis is targeting, which is those regional flights. The biggest challenge that we really have to solve is one around thermal management for fuel cells. We use SpeedGoat in combination with Simulink. The value of hardware in the loop particularly is about de-risking our development, so we can show up behaviors in hardware in the loop testing that we wouldn't get from purely software modeling, because it's always impossible to fully capture the behavior of those hardware elements, particularly if they involve complex thermodynamic interactions or complex software systems. The level of fidelity that we're able to achieve in our model shows up all kinds of behaviors and allows us to predict things that we would not have expected through a more conventional engineering design process. We've been able to be preemptive and starting to implement different solutions or to choose different components to fill those gaps we've identified.
So we actually had exposure to the MathWorks Startup Program at a previous company that we worked at. And so at Stralis, we really decided to jump into this program early on because it's a very affordable way for a startup like us to get access to a huge suite of really valuable, capable tools. It gives us much more firepower and capability in our simulation and testing environment.
The real benefit that I see of this startup program is that we do have access to all the tools. So that means that we've been able to use the full capabilities of the software suite. I'm proud to work at Stralis because we have a real world problem that we're trying to solve and that needs to be solved for a sustainable future.